Okay, so problem 5 again is very similar to problem 4. And one way to think about this problem is that this is equivalent. So this is your problem, right? This is equivalent to just flipping it backwards. Sorry, the arrows are going the opposite way. So these two are equivalent. You already have diagrams for this one and diagrams for this one, right? So similar to problem 4, you are going to use those results from problems 1 and 3 and get your reactions directly. You don't have to recalculate anything. You do need to keep track of the signs, however. So you originally had a downward triangular load. If you just put a negative sign in front of your results, that'll become an upward triangular load. So in other words, your AY5 will just be equal to negative AY1 times 2 plus, and I won't solve this all out for you, but you get the idea here. And other than that, like, follow the same thing for problem 4. The main thing that I'm gonna spend the rest of this asking about problem 6. Problem 5 and 6 are basically tied together. For number 6 is just basically asking you to plug in values for your forces here. So plug in a value for W and plug in a value for L. I think L is given to you directly. The only thing you have to think about is W. Kilopascals is a pressure unit. In other words, it's a force over an area. Your W is a force per unit length. So if I want to go from one to the other, I need to multiply this 1.5 kPa by some length in order to get a force per unit length. That is what this spacing, spaced every 5 meters, is supposed to signify. So you can imagine what he's getting at is, pretend that you have a building, or you have a building that's composed mostly of these elements spaced every 5 meters. And let's say that you had like a wall and a roof on top of this building, and that is applying, well, it's applying suction actually. I drew all these arrows wrong. You have suction, 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 suction everywhere. This is where you have your kilopascals. This is your kPa. You have these frames spaced every 5 meters. And you need to find out what is the load that each of these beams sees, each of these frames sees. And we call that a tributary load, if you will. So you want to just find your tributary area, or tributary width in this case, and say, well, these are spaced every 5 meters, so this frame sees everything in 2.5 meters on either side of it. So basically, your W is just equal to 1.5 times 5. That is for this horizontal case. For your vertical case, it's a little bit different. Your vertical case, up here will be 3, down here will be 0. So that's the main thing. He's really trying, this is going to go back towards your project a little bit, and this is really what you're going to be, this is really what civil engineering is about. You're going to try and take, if you go into structural engineering at least, in the future you'll be looking at, for example, in your capstone course, you're going to be looking at it, you're going to have to design a building, and you're going to say, well, you're going to have to find the forces. A lot of the information is given to you here. This information usually wouldn't be given to you. The client would expect you to take to look at the site, for example, to look at a map and say, well, in this particular area, because of the local topography, maybe you're by the river, or maybe you're on top of a hill, you would have a wind pressure of this much, and then you could play around with it. Like, and you would be expected to, for example, play around with the spacing. Maybe if we space these every 4 meters, we can use a smaller cross section, a smaller frame. Or maybe if we space them at every 10 meters, we use a larger frame, but we have to use, we can save money by using fewer of them. So those are like the kinds of things that that the professor is trying to get you to start thinking about. This is kind of like your first step. So if you're interested in like pursuing structural engineering, this is more similar to what you'll be asked to do in the future. That's just a little bit of a side note there to get you guys thinking about this, but that's really the bigger picture. This is leading into something else. So if you have any questions on the problems, I know that there's 6 problems. It looks like it looks time consuming, but the reality is that there's a lot of redundancy in here, so you don't have to spend that much time. You shouldn't be spending hours and hours and hours rederiving everything. With that, let us know if you have any questions.